Section 1.3, using the midpoint and distance formulas. To introduce us to this picture, or to this unit here, we've got a picture by an artist who has discovered that sometimes ants make really cool pictures. And he's got this breed of ants that has transparent abdomens, and because of their transparent abdomens, he was able to feed them colored sugar water, which did not harm the ants at all, but it left kind of some rainbow ants and left them in some cool colors. And it was really neat to see the pictures of ants that went from one droplet of sugar water to another droplet and kind of had some mixed colors. So that was a really neat thing. Some more pictures to come on colorful ants. You guys did very well on the pretest portion that dealt with line segments, so we're going to bypass section 1.2, but we do need to cover some of the vocabulary from that. Section 1.2, the first word we're going to look at is a postulate. And a postulate is a rule that we accept without proof. This is also known as an axiom. And axioms, it's like, okay, so let's say you've got a line segment. And over here we have point A. Over here we have point B. And somewhere in the middle is point C. Well, one of the postulates says that if you take this whole length AB, that's the same as taking AC plus CB. So that's kind of one of those duh, really we actually need to spell it out type moments. And that's what postulates are. It's accepted without proof. You don't have to go through the math to prove that that's true. We just kind of accept that it is. Congruent segments. When we have segments that are the same length, we say that those segments are congruent. And here's our congruence symbol. It's an equal sign with a squiggly line over the top. If the lengths of the line segments are equal, we can say that the lengths are equal, or you can say that the segments are congruent to each other. Uncovered a little too much there. Our next term, midpoint. A midpoint is a point that divides the segment into two congruent segments. So midpoint, it just kind of means the middle. So between A and B, M is the midpoint when AM is the same length as MB. And that's what these little symbols here mean. These little symbols say that these two spots are the same length. A segment bisector is anything such as a point, a ray, a line segment, or a plane that intersects the segment at its midpoint. So point M up here is a segment bisector. If I had a line going through, that line would also, if it were actually a straight line, that line M, would also be a segment bisector because it's bisecting line segment AB at its midpoint. So let's look at example 1. We're finding the length of AB, so this whole line segment, if AC is 2 1/4 inches. Okay, well, if the whole thing is 2 1/4 inches, then we know that ray CD is the bisector because we've got these two slashes here. So point C is the midpoint. So AC is 2 1/4 inches. CB is also going to be 2 1/4 inches. So this is 2 1/4. This length is also 2 1/4. And I want the length of AB, so this whole line segment all the way down. So for the whole line segment, I'm just going to add these two pieces together. So that's going to be 4 2/4 or 4 1/2 inches. Example 2. Point M is the midpoint of JL. Find the length of ML. So I'm going to give us a little bit more room here first. M is the midpoint, so we know that JM is going to be congruent to ML. So since they're congruent, their measurements are equivalent. So all I have to do is set these two expressions equal to each other. So 3x minus 2 is going to equal 2x plus 3. I'm going to draw my line through my equal sign, just like we did way back in algebra, and do some inverse operations. So to get my x's on the same side, I'll subtract 2x from each side. That leaves me with x minus 2 equaling 3. Add 2 to each side. And x equals 5. Now I've still not answered the question. The question didn't want x, the question wanted the length of ML. So ML is here, so I'm going to take that 5 and substitute it in for x. So 2 times 5 plus 3 gives me 10 plus 3, or 13. So the length of ML is 13 units. The midpoint formula. For the midpoint formula, oh, actually, hang on, I've got, nope, okay, sorry. Midpoint formula looks like a bunch of mumbo jumbo, but it's really not too bad. Basically what it says, if you have 2 points, so point A and point B, you're going to kind of find the mean of the x's and the mean of the y's to find the midpoint of that particular line segment. So we'll take our 2 x's, add them together, and divide by 2, and then take our 2 y's, divide them together, or add them together and divide by 2 to get the y portion of the coordinate. So let's see that in action. We've got the ordered pair 7, -2 and -5, -6. So for the midpoint, we'll go ahead and call that M for midpoint. That's simply going to be the sum of my x's, so 7 plus -5 over 2. Let's make that negative more pronounced. For my x part of my coordinate, my y part of my coordinate, I'm going to go back to point G, and that's -2 plus -6 over 2. So it wants the middle. So it's basically finding, like I said, the average of those two pieces in order to get to the coordinates. 7 plus -5 is going to be 2, and 2 over 2 simplifies to 1. -2 and -6 is -8. -8 divided by 2 is -4. So my ordered pair for the midpoint is 1, -4. Your turn. Find the midpoint between 819 and 2, -3. Pause your video at this time. The midpoint is 5, 8. If you got it correct, give yourself a mustached smiley face. Here, we'll give him a big grin too. If you did not get it right, give yourself an X until you can find your mistake. Go back and review the midpoint problem that I just completed. Once you get it correct, give yourself a circle around that. Next, we're going to be looking at the distance formula. Distance formula is actually going to encompass some of the Pythagorean theorem we were dealing with last year. For the distance formula, you've got 2 points. You're going to take the difference of your x's squared and add to it the difference in your y squared. For an example, we've got 5, -1 and -3, 6. So our line segment length for GH is going to be the square root of the difference in our x's squared. So 5 minus -3 squared plus the difference in my y squared. So plus -1 minus 6 squared. Simplifying, 5 minus -3, do a leaf change opposite. That's 8 squared, or 64. Leaf change opposite here. -1 plus -6 is a -7. -7 times -7 is going to be a positive 49. From here, add these two pieces together. Let's see, 4 and 9 is 13, 6 and 4 is 10, and 1 more is 11. So we've got square root of 113. If we take that into our calculator, the square root of 113 is going to give us approximately 10 6/10 when we round to the nearest tenth. Your turn. Pause your video at this point and try this problem on your own. Did you get 6 71/100ths? If you did, give yourself a firework. Because like the 4th of July, you guys are the bomb. You guys are awesome. Hopefully it looks a little bit more firework-like and a little less crazy spider-like than mine does. If you didn't get it correct, give yourself an X. Go back and try it again. Once you figure it out, circle your answer. Look for the problems on the chalkboard for today.